As we have seen, the standard deviation is an important measure of variation in a data set. This spreadsheet has been designed to demonstrate the mechanics of calculating the standard deviation, and ultimately we'll show you how to use the function keys to do the job quickly and easily. But it's important that we go through this exercise, and particularly important that you understand what is meant by the term sums of squares of deviations, because this term will be used in later lectures. Here we have a data set which represents the height of a human population, and as you can see by the tabs below, we have two other data sets for weight and girth. In each case we have a little bit of data and we have some instructions that you can follow in order to complete the exercise. So here we have the heights of 10 people. The first thing you do when you look at a set of data is just check that the data has been input correctly. So you should really go back to your record sheet and check that every item of information is correct as it was on that record sheet. You can glance through a set of data and sometimes you can see that the typist has made mistakes. So if in the first item here the typist had forgotten the decimal point, then you would have had someone who was 172 meters tall, and obviously you would need to go back and check what the correct value was and make sure that it was input there. So on to the exercise. The first thing I'm asking you to do is to use the function key to put the average value in cell A12. So here we go up to the function key and you see the range of functions that are available to us. We have used the average quite recently and so there it is. If it wasn't there, we could select from this range, so we could select that we wanted to look in all of the functions, and we could type up here that we wanted to identify a particular function. So for example, we might like to find the minimum and go, and there you can see that you have a function called min, which returns the smallest number of a set of values. So that's just a handy hint if you're using a computer which hasn't used all of these functions in the past. But it will store your most recently used ones for a little while for you. So we're selecting the average, we OK, and you can see up here that it's using the cell range addresses A2 to A11, which is the range of addresses where your data is. So that's all right. And we have a mean value of 1.726 meters. Now what we want to do is work out the deviations of each value we've observed and recorded from this mean value. So in cell B2 we're going to put in an equation to work out the deviation, and we type equals A2 minus the mean. Hit return, and we see that we've got a very small negative deviation, that this individual at 1.72 meters is 0.006 meters smaller than the average. Now we need to copy this equation down, and if you just simply do copy, you will get the wrong answers. We need to make sure that the reference to the cell A2 is carried on down, and we do that by inserting a dollar symbol either side of the A in the A12. Hit return, and now if we copy that down, we will get all of the deviations. Now we would expect the deviations to sum to 0. For every positive deviation we have a negative deviation. So when we add them up, the answer should be nothing. To check that, we'll use the function for sum and OK, And now we're adding up the values in the cell addresses B2 to B11. Click OK, and it doesn't say 0. We have a problem here in that the computer is rounding up and we get some residual value which is due to that rounding up process. But we get this strange number, minus 1.998. It's a negative number, but the E minus 15 means that we have to move the decimal point 15 places to the left. So in reality, that number is 0.140198. It's as near to 0 as matters. So that demonstrates that if we add up the deviations, we get the answer 0. Now we need to square the deviations. And there are two ways in which we could do that. We could do equals B2 multiplied by B2. Or, and here we've got one of these funny E numbers again, in this case we would need to take the decimal place 5 places to the left. Or alternatively, what we could do is equals, and here we've got B3, and we hit uppercase 6 to give us the upwards arrow, and 2, which is the equivalent of saying the value which is in cell B3 squared. So we can copy that down for all of our deviations. Now we want to calculate the sums of the squared deviations. So we'll use the sum function again, and here checking, we're using the values in the cell range C2 to C11 and hit OK. So I'll just write underneath that that value there is SS for sums of squares. Okay? Then we need to use the sums of squares to calculate the variance. So if you can remember the formula for the variance, we have the variance is equal to the sums of squares divided by the number of observations in our sample minus 1. In other words, divided by the degrees of freedom. So we need to therefore go up to this cell and put in the equation equals the sums of squares divided by 10 minus 1, which is 9, hit return, and so we have in this cell our variance. So I'll type underneath that that is the variance, just to remind you what it is. Now, to get from the variance to the standard deviation, we need the equation standard deviation equals the square root of the variance. So the easiest way to do this calculation is to use the function key for square root, and it's squirt. Give it the cell address next door, so the square root of the variance is equal to 0.0766. Let me just write under that that is the standard deviation. Okay? Now, I did say that I would show you the function way of doing this, and so here we can use the functions to work out the variance, for example. So we have a function called var. var estimates the variance based on a sample. So if we click OK, just check our cell addresses are between A2 and A11, or else we'll get the wrong value. And just check that our variances, that's what our function has given us, and that is the value that we calculated ourselves. So our variances are correctly calculated, and then we'll come here and use the functions to calculate the standard deviation, which is stdev, estimates the standard deviation based on a sample. You've got to be very careful because the calculation for standard deviation or variance based on the population is slightly different from that which is based on a sample. So we'll accept that and modify our range of cell addresses to 11 to make sure we get the right value. And again, you can see that the value of 0.0766 is the same as the one that we had calculated before. So we have done everything correctly. Now, our final instruction is to work out the coefficient of variation and express it as a percentage. The coefficient of variation, you might remember, is equal to the standard deviation divided by the mean of the sample. And if we want to express it as a percentage, we must multiply by 100. So if somewhere we put in that equation, I just click there and type in coefficient of variation, that is going to equal the standard deviation divided by the mean. As a proportion, it works out at 0.044, but we want it as a percentage, so we need to put brackets around this equation and multiply by 100, and we get 4.44%. Now, the coefficient of variation is a useful way of looking at the data. It gives you an idea as to whether your data is as variable as you might expect it to be. So, as a sheep geneticist, I know that the coefficient of variation of growth rate in lambs is usually about 15 to 20%. If I found a value of 4.4%, I would wonder why the variation in my data set was so low. So that's a kind of example of the use of the coefficient of variation. Now, the final instruction that you have is to repeat the exercise for weight and girth data and try to familiarize yourself with the terminology, particularly what do we mean by the sums of the squares of the deviations, because, as I say, that is a term that you're going to use later on, and then you will also have a quiz which is associated with the exercise, and it will just check that you've got the right values and that you understand what you're doing. In each case, you've got the instructions to follow on the spreadsheet as well. So, all the best.